Statistical variance uses numerical data to make inferences from a sample. When applied to schedule performance, it can set plausible high and low bounds for estimated duration. The bounds, along with the nominal estimate at complete for time, are useful for decision making on a project. Calculation of plausible high and low bounds is founded on building blocks. They come from earned value management and statistical analysis. From earned value management, get the planned value, get the earned value, calculate the earned schedule, calculate the schedule performance index for time. We need both the cumulative and periodic amounts. Historical SPIT is the basis for statistical analysis, but analysis of periodic SPIT from real projects revealed a problem. The SPIT is skewed. It's not the right shape for statistical analysis. Applying the natural log to each SPIT gives us this. The log data is in a bell-shaped curve that supports common statistical techniques such as sample mean, sample variance, and sample standard deviation. Calculate the mean. Sum the log of the periodic SPIT, that's x, and divide by the number of measurements. Because it's a sample, it's n minus 1. Next, calculate sample variance. First, find the difference between each log of periodic SPIT and the current mean. Square the differences. If we square the right, we must square the left. Finally, divide by the number of measurements less 1. Calculate the standard deviation. It's the square root of the variance. From the mean and the standard deviation, calculate the spread of values. Is that spread the range of plausible bounds? No, that's the average dispersion around the mean. To know plausible bounds, we need a better idea of the distribution of measurements under the curve. Under the curve, the total area is, by definition, 100%. That area includes outliers, but they are not likely values. So, narrow the area. Say we only want measurements within 95% of the area under the curve. We can calculate the distance from the mean for any individual measurement. The distance is measured in units of standard deviation. It's the normal score. Take, for example, this point right here. The distance is about 2 standard deviations from the mean. More precisely, the normal score is 1.96 deviations from the mean. What's neat is that if you have a score, you can reverse the process. You can infer the area under the curve given the score. We'll use a score in the next video. There, we use building blocks to construct plausible bounds for duration estimates. For now, let's review the building blocks. High and low bounds for duration estimates are based on historical schedule performance. Schedule performance is expressed by SPIT, but it has the wrong shape for statistical analysis. The log of the SPIT has the right shape. Find the sample mean, sample variance, sample standard deviation. Finally, find the score. For more information on earned schedule topics, here are some references.